a few seconds before that. Okay, so I think we'll start now. I'm going to share my screen. I think I hope if you guys can confirm if you can see my screen. Right. Just allow me 2 seconds. Okay. Just going to share. Yeah, trying to just give a minute. Okay. Okay, I'm not sure if you guys can see my screen. Let's see if I can go back. Okay. Okay. Now, I don't know if anybody can confirm. They can hear my screen. You see my screen?
Yes, I can.
Okay. All right. Okay. Thank you so much. I'm going to start now. All right. Okay. Okay. So I think the topic of today is for us to discuss what we call responsible AI, but obviously with the link with the automation. So yeah, obviously we know that automation, as far as we're concerned, is converting manual work into some kind of an automated way of doing things, whether it's a robot or whether it's some kind of a software, a robot, or it's a human, or let me say a physical robot, or a human or a software robot. So that's literally what we call automation. Yeah. So what we're trying to talk about in terms of what we call responsible AI is the moment you remove the human and you use a physical robot or you use a software robot, there is some ethics that will happen. Now you're taking the responsibility of the human to a non-human. So there has to be, there will be some bias that will happen. There will be some kind of mistakes that can happen depending on the automation model that you're looking at. So balancing innovation and ethics is what we're trying to discuss today. So as AI integrates into business workflows, ethical considerations have to be prioritized. I think that's exactly what we're talking about alongside innovation. All right, so the agenda for the topic is to obviously discuss what is workflow automation. I think everyone's quite aware. We obviously, as part of our pre-trailer chapter, we obviously represent Camunda, and Camunda is one of the major workflow engines, as much as we've got other engines from different vendors and also some open source vendors in the same league. Then we'll also look at probably some of these responsible AI integration trains, then the implications, some of the case studies, the governance and frameworks, and also we'll discuss some future outlook, and the Q&A will ultimately follow. All right, so obviously, I mean, when you talk automation, it's literally using digital tools to streamline processes, whether in the HR division, or in the finance, or customer service. And AI can actually then bring in some speed and efficiency and adaptability into it, in the sense that in some cases where we were relying on some kind of predefined rules, then AI actually takes away that. But there is some risk in that, which is what we're trying to discuss today. So, okay, so when we discuss AI and business process automation, what are we talking about? Do we want to enhance decision making? Because by nature and by tradition, automation just has got predefined rules that you put in a table, in a database, and you then compute to create an API into it, read the API and get the feedback, and then the feedback becomes your input into your workflow, whether to go A or B, as far as your routing in your workflow is concerned. So over and above that, it also reduces operational cost as far as AI is concerned, because what you do know is AI normally will entail you removing some kind of a human activity as well. And by removing that human, you're also removing delay in terms of operational cost. You're also removing some kind of human bias. So like I'm saying, there's the human himself is biased in every sense of the word, but the AI is also biased in the sense of the word. So by moving to the AI, we're removing the human bias, but we're introducing the AI bias. So that's literally what we're looking at. Then we can be able to scale complex processes, that's for sure. In some cases, and we can improve customer experience. That's yeah. So I think before we go far, we also want to look at, okay, what are we looking at when you talk AI? We're looking at different algorithms within the AI space. We've got what we call supervised algorithms, like linear regression, like logistics, regression, and decision trees. The good things about these ones, these are based on standard mathematics, and they're still quite very close to traditional straightforward rules that you put in a database. They're based on specific mathematical formula, so they can't be black box. So we know exactly that the input into these algorithms is exactly, so they literally termed what we call a white box in terms of interpretability. So in that case, they literally introduce almost zero risk because they're very clear in what they do, but they've got their own bias. They've got their own bias in the calculation based on the accuracy and stuff like that. So that's the problem. But the good thing is they're very, very clear in what they do. Everybody can expect the outcome of this algorithm. So it's quite very straightforward. Then when you go into what they call black box algorithms, this one's a bit of a problem. You look at things like your gradient boosting, random forest. Then if you go down into maybe most of the popular algorithms of today, where we talk about deep learning, these are the ones that they're also supervised in some way. So they're based on some input data, and obviously they work on that input data, whether images or not. But they are black box. That's the problem. So they're based on, obviously there's a whole lot of mathematics, some integration algorithms that you're looking at, but the problem is they are black box. Now the same with your large language models, which is what we call transformers, whether it's the Bayes or the GPT algorithm. They're also based on supervised. You pre-train them, then from the pre-training, then you literally. But this is the thing; they're also black box as well. And in some cases, for some of these transformer algorithms, what you will find is also the in terms of the size of the data. Also gets to impact the quality of the output. That applies to most of the algorithms. The less the data, the less the outcome of what you're trying to do. Then if you look at what they call unsupervised algorithms, like your clustering, your k-means, these ones are quite very clear because they are not black box. That's a good thing as well. And obviously look at algorithms like PCA. Then if you look at your generative adversarial networks, these are unsupervised learning. In the sense that they just get some large tons of data, they work on it and they will generate some kind of an output, but at least, but they are black box. That's the challenge that you're looking at, right? So that's what we're trying to discuss, just the impact of this black box issue and other factors that these algorithms that are going to include. So when you embed this in a workflow, what are the risks that we're bringing in? So that's what we're looking at. So when we have workflows, standard workflows, every state goes on another human, approve, reject, and all that. That's traditionally what we've been doing. But this is the problem that happens. There is delays, of course. The rules are rigid. So which means you can't really change the rules. So that's why AI come in and say, no, look, come in, we can actually be able to feed the data, learn the data, and adopt and move as we go. So that's quite a very important thing, right? So, but this is what comes out of it in terms of the implications. There is what they call algorithm bias. So in this case, there's bias in the training of data. So when you normally use a model, it's literally the outcome of a model that's been trained on some input data before that as an AI algorithm. So that's the first thing that you look at. The question is, how do you mitigate that? You obviously have to use representatives of diverse data, and you have to do regular bias audits on the data. I can give an example. I mean, there's obviously been a cry around facial recognition among different colors of people, whether it's the Black community and the white community. So those are things that have been quite a big discussion in the AI world. So those are things that gets introduced, obviously, in terms of that. But like I said, I mean, it's not to say the human who was doing this work before was not biased. He was biased in some cases, but it's just now the software itself is introducing its own level of bias. But the question how we mitigate it is exactly what we're looking at. Then the other one is what we then look at is what we call lack of explainability, right? So an opaque model makes it difficult to understand what it is doing. So the previous slide I spoke about black box and white box. So that's what we're talking about. So in some cases, you put your input into some mathematical algorithm, which you know exactly the way that it computes, whether it's ax plus b or d over y, the square root of 3, it doesn't matter. So you know exactly the output that comes out of it. So it's not really opaque, right? But the models that you saw that way, black box, all those are opaque. So you've got a problem in those kind of stuff. So the question is obviously is how do you mitigate those kind of stuff? Is obviously we introduced is what you call explainable AI techniques like Lime and Sharp that will literally come and try to help to make these models interpretable. That's what we're looking at. So then we've got privacy violations. That's what AI actually introduces, of course, because the training data that was used, most of the cases we've all seen people crying that, where did you get the training data, whether it's Google or whatever vendor that you're looking at. Sometimes they're collecting data online. The question is, did they get it by consent? Maybe yes, maybe no. So there have been lots of test cases around this. Then, so you have misuse of personal or sensitive data in building these models, which is actually a problem. And I think when you look at corporates, it's even more worse because these models sometimes don't even have data in terms of the company data. So, and if they try to use this model, they might be exposing their data to the outside world, which is actually not correct. Then there's accountability issues as well, which is to say, it's very unclear who is responsible when this system fails. The question is, who do you sue? So what happens if somebody goes into a bank and applies for a loan, and the person says, I'm not going to give you a loan? What it means is that person is taking responsibility and can go into a court of law to say, I didn't give this person a loan because A, B, and C, right? Whether I was wrong or not is not a problem, but there is accountability. The question is if a company uses an AI model and it fails. I mean, we saw last week, there was a model that deleted the whole data set in a certain company in the US. The question, who is responsible? You understand? So they use a model, and that model literally wiped all the data in that company. And the question is, do they maybe go to whoever was the trainer of the model, or maybe they didn't use the model correctly? It becomes very difficult, right? So the question is, how do you mitigate that? Then we've got different mechanisms, like what you call human in the middle loop, and all that. So those are some of the mitigation strategies that you look at when it comes to responsible AI and explainable AI. So I'm just looking at a good example here, which is a loan approval, like I just explained. Naturally and traditionally, what would happen, we would create a workflow, we would assign a task to a credit consultant. Credit consultant would view the application details, whether in physical form, or in some cases, or maybe on a computer, and they will look at the data and they can make a decision, whether it's biased or not biased, but they're taking responsibility. Then, so the question is, when we introduce AI to say, now we don't want a human to do this assessment, we want an AI model to look at the document, assess the document, make a decision out of it. What are the risks? There's biased data leading to unfair denial. That's definitely what can happen. There's lack of transparency, because at the end of the day, even eventually when the customer gets a decline, they have no clue. They can even go to the bank and say, I got declined. Even the bank consultant has no idea why it was denied. So that's literally exactly the problem. Those are the more popular models like your neural networks and stuff like that, but this is what they're introducing. So the question is, how do you make sure that there is no bias? Is you need to have a lot of data to be able to actually, then you need what they call human oversight. So in that case, human oversight, whether it's in the case where there's some kind of analysis, assessment of the outcome of the results, that's something, those are some of the decisions that can be done. I was looking at a workflow here, which obviously doesn't have an AI component as such, and literally based on specific AI in the database and stuff like that. It checks your credit worthiness, checks your compliance in terms of your KYC and all that. So this is before we've introduced AI, right? And like I said, there's also its own risk here. There's operational bottlenecks. There's rigid rules that are in the database that are based on these APIs. So it becomes quite very difficult in terms of actually having dynamic workflows in that sense. So that's what you're looking at. Then if I look at this kind of workflow, which is literally also doing KYC, but literally says, you know what, I don't want that human that was literally looking at the KYC document. I don't want that human that was looking at the compliance document. I'm going to go and call OpenAI, and OpenAI, I'm going to give it this document. I'm going to ask OpenAI, say, please review this ID document. Please review this proof of residence and tell me whether you're accepting this customer or not, right? So that's literally what we're looking at. And I think here what we have done is to actually put that human oversight to say if it can't decide, then it needs to go to a human. So that's what we're looking at, right? In that scenario. So that's exactly an example of a workflow where we've introduced AI in this case. So then I'll also introduce another workflow, which is an HR process automation. Uses AI to recruit, goes into LinkedIn, picks up profiles. Well, we know the data quality on LinkedIn, is it correct? Yes or no? It's debatable, right? Because people have put a whole lot of fake stuff in there. You understand my point? So that's the first thing. So in terms of that, the other part, there is quite gender bias in the sense that obviously if it looks at images, we have known that some of these models have got gender bottleneck in terms of, or race bottleneck as well, in that sense. You know, you got a point. Then the question is, how do you also mitigate that? Then you need some kind of a regular audit. Yeah, so, okay, so if you look at what are some of the approaches to build what we call an ethical AI workflow, we obviously want to build on specific principles. One of the first principles is to say ethics must guide what we do, right? We should align to the ethical norms of fairness, transparent, and respect of the rights of the individuals, customers, or employees, or the general public per se, right? So we should use the tools that we have to enforce those ethical constraints. Then there has to be human oversight wherever they can. Human oversight is critical in sensitive and high-stake decision making. Then, so you implement what you call a human in the loop to approve or override specific AI decisions. Then you also then look at the principle of what they call boost the trust and sustainability. So in that case, with creating some transparency and fairness. So for us, for people to trust, we need to show some audit documents. So one of the key things in a workflow is to have specific audits at every point to show people what happened in the workflow. That's quite very important, because then at least people can see, okay, this is something was done on point A, point B, point C. So that's what we call creating trust and sustainability into an AI-based workflow, right? Then, so like I said, one of the mitigation factors is to introduce what we call a human in the loop task for automation. And what happens is, for a human in the loop component, there's a couple of capabilities that you're looking at in your workflow, whether it's, look, obviously we're using Camunda here, but it applies for any process modeling tool. A validation checkpoint is a task where a human must review and approve the AI's decision before it proceeds. So that's one. So you still allow the AI model to do the work. So why would you do that? Then maybe you can ask. The question is, maybe it takes a full day for a consultant to do the work, and AI maybe can do that in 20 minutes. But then what helps is if there is a human that then reviews the outcome, it can be able to pick up straightforward anomalies, and it doesn't have to do the work in a full day. So that's literally what we call, it's kind of a meet in the middle. So it's a manual approval task after the fraud detection is flagged a transaction. So then the fact that the transaction was picked up is something that a human might not have been able to, right? So in this case, when the human then sees the transaction, they can be able to say, oh, no, but this is not correct, right? So then they can do the over and correct, Then there's an override trigger that allows humans to alter or reverse AI-generated outcomes, which is exactly what I was talking about. So a reject override option is if AI recommends a loan denial and doesn't give you a reason, right? So in that case, it becomes a problem if the model doesn't give you a reason in that sense as well. Then there's what we call an escalation part, where workflow routes that sends complex or sensitive data to human agents in that sense. So you can route medical insurance claims above 10,000 to a human reviewer. So you can literally say, maybe for low-level values, the agent should just let it through for in this case, for a claim. But anything above $1 million, definitely a human has to be involved. So you're creating some kind of a balance, especially on high-value transactions. Then we've got an appeal mechanism where you provide users to affected by an AI decision to actually request a human to review. So in some cases, we call it arbitration in the world of business. So in that case, you could literally send an outcome to a customer to say, this is the decision, but obviously then you could be able to just outline the reason. And if the customer is not happy, they can actually say they want arbitration of the decision, and the decision in this case, because the customer is doing arbitration, doesn't have to go to the model, to go to the AI, to the human to actually review it, right? Then there is also what we call an explanation dialogue, which is a report showing why AI made a decision to aid a human, right? So in this case, if the human wants to review the outcome of these AI processes, then they will see a report. For instance, you've got what we call the sharp explanation chart that can be embedded in a denied loan in that sense. So sharp is one of the frameworks of explainable AI, which is a very big branch of AI as well. Then you've got an audit trail. I think we've already discussed about it. Then we've got what you call a feedback loop. Human input is fed back into the model. So what happens is, all these things where the model didn't do correct, what it does, it will actually take back the learning and say, oh, I did this wrong, right? Then it learns it so that next time it doesn't do the same mistake. Like I said, I mean, a modern AI model is based on learning on the data. And the fact that it allows the human to also correct it as it goes, it actually gets that input and puts it back into the model and trains it and make it better for tomorrow. I mean, you've seen it when you talk of your ChatGPTs and stuff. Sometimes they give you wrong things and you correct it. This is what's happening in the background. The model is actually learning from people using it, right? So that's why they call the feedback loop component, then that allow retraining of the algorithm. So, all right. Then obviously some of the mitigation is actually using diverse data sets, so which is exactly what we spoke about. So we've got what we call bias mitigation, where diverse data sets reduce the risk of bias by representing different demographics, behavior, and scenarios. So you can actually be able to manage that. Then this make sure that your hiring models, your credit models, or your claim models actually not biased because you use a specific data set. Then there's fairness enforcement, where you ensure that the model doesn't disproportionately impact certain groups, right? So you train an AI model that fits into a DMN decision model. This is inclusive with inclusive data set. So your geography of your data, your gender of your data should actually be so diverse that at least it includes all the groups of the potential people that you use the system later on. Then there's regulatory compliance, where you help where it helps meet legal and ethical mandates. So there's different AI acts that have been defined all over the world. The EU Act in America, you've got all this, and some of these they're actually saying your model should be fair. I think only yesterday, there were some 6 or so signatures that were signed by President Trump, and one of it was literally talking about ensuring and making sure that models are fair. And so you use process gateways to validate fairness and scores from decisions. Then you also need to have what you call robust model behavior, where a trained model can vary and resistant in the real world. So in that case, obviously, you improve accuracy. But one of the key things that's important is to actually have audits. You should have traceability and transparency in the activities of the model, right? So there has to be some logs and metadata that should be in the workflow, capturing whatever came out of the AI model, and so be able to output what happened. Then there's what you call inclusive designs, where you support broader access and different this is more or less very close to the fact that you need to vary the data set. Right. So then if I also look at some of the key things that you look at is bias detection metrics. What kind of metrics would you use? So in this case, to ensure fairness, you can actually use what they call explainable or responsible AI toolkits that are out there, like the AIF 360 toolkit. What it does, it actually makes sure that you have actually catered for all genders in your model, right? So you can actually use these kind of toolkits, responsible AI toolkits, that actually validate your toolkits to see that it's a fair model, right? Then there's what you call scheduled evaluation, where you can actually periodically or quarterly you can run some audits against this model that you've got. Then sometimes you can have bias in your decision gates in your workflow, right? So why am I saying that? So your DMN decisions to ensure rules do not unintentionally favor one group over another, or attach monitoring to DMN. So you could say, maybe if you wanted to say you want a pass rate for facial recognition, if you pick 80%, the question is 80% the right one or not? Or in terms of the accuracy of your algorithm, is 85 correct? What if somebody gets 81.2 or 84.5? So those, especially those gray lines, the question is, if you deny that, is it fair? Is it not? You understand? So those are some of the things that you look at. Then in some cases, you can actually have these validations to say, if the racial bias, for instance, excludes 0.2, then our audit is going to fail this model. That's what you're looking at. So it's actually looking at something like that. So the question also about retraining your model is also quite important, especially in language models and all that kind of stuff. Then you also have to have documentation of your audits, of course, right? Then let me come to the explainability component, which I said is quite very, very key as part of responsible AI. So explainability is a subset of explainable AI. So what explainability says, I should be able to explain my AI decision, right? And for us to do that, for us to do that, I should be able to use this explainable AI algorithms that can be able to actually validate whether your model is compliant with it. Then there's what we call a global transparency model, which actually offers insight into how AI model works and then looks at the output of it. Then there's visual aids. That's a good thing about workflow models. They are BPN models. They can show exactly how the flow works, which makes it much easier, and visibility is actually very important in this case. Then you've got obviously other issues like logs and stuff like that. So, I mean, you can have a decision log like risk too high due to credit score, income and debt income ratio. So that's your explanation. So that's very clear. So if a credit consultant sees this, knows exactly why you were denied, right? So they can't really. Then there's application denied due to low availability and recent missed payments. Very clear, right? Very clear. So we can actually show the client, and the client can actually not necessarily question that, right? Then, so explainable AI, like I was saying, it refers to methods and techniques in AI that makes it the results of the model to be understandable by humans and also agreed by the humans to say this is fair. They promote transparency, they build trust, they ensure auditing is happening, and they also ensure that the model can be debugged, and we can see exactly what's happening, right? So that's literally your key component. They promote the transparency by having these chats before decision tasks in a workflow. They build trust and confidence by actually building some audit trails, and they also aid in the AI debugging behavior. You understand? Then when we talk of examples of these AI, explainable AI algorithms, so these are some of the methods, like the LIME method, which provides human understandable reasons why you were denied, right? So that's the LIME methodology. Then we've got the SHARP methodology that uses mathematical game theory to assign a contribution to each input feature. So it's able to say, we did deny you because 70% of the day of your your assessment was based on maybe your loan payment behavior, right? Which is very bad. So we associate, we put 70% towards that behavior. So it's actually break it down mathematically using game theory. For those that have done mathematics, game theory is one of the major components in the mathematics world. Then we've got black box and white box. I mean, you saw decision tree was one of the white box models. They are very interpretable. Black box are not, which is a problem, right? So in this case, you have to use these things like SHARP or LIME when invoking a machine learning model. So you have to invoke it first so that you can be able to explain the outcome of that machine learning model, because the model itself can't explain it, right? So you have to use it as a combination in that sense. Then when you look at images, it's also a very difficult scenario. Visual explanation of an image is actually very difficult. So, but your CNNs and stuff like that, that's the job, right? They will display the heat map and the quality of the outcome. And there's what you call a counterfactual explanation, which tells you how the inputs can be changed to alter the outcome. That's quite important to say, okay, we were denied, but what could have been done? What if? What could have caused you to have a positive outcome? So this kind of explanation is a methodology in explainable AI that helps and tells you that kind of stuff, right? So like I said, that being responsible AI, which is obviously the superset of explainable AI, is 5 key principles: fairness, transparency, accountability, privacy, human-centered design. That's 5 core components. So here I just put it so that you can be able to understand the difference between these two. The responsible AI is looking at the broader scope, right? And explainable is only focused on the it's a subset of responsible AI. But what it does, it says, I'm there just to explain to humans why the output was A, B, or C. That's the only thing that explainable AI comes in and assists AI. But obviously, responsible AI is talking deeper. It's talking about fairness, safety, ethics, and alignment to society values based on your culture and everything. That's responsible AI. And explainable is a subset of that. Then you've got what we call core focus, which is looking at what is the fairness, what are governance and accountability tools that you can use. And explainability is looking at the interpretability of the outcome of the model, right? Then goals is what goals are you looking at from responsible AI, because it covers everything. It says, what is it that benefits society? What is it that harms the society? What is ethically wrong? What is ethically not correct? Right? That's responsible AI. But when it comes to explainable AI, it's literally saying, how can human understand what came out of this model? That's their goal. You understand? Then when it comes to application, you can embed this in different models, but you're looking at ethical reviews that come out of it. And this one is just shows you why decisions were made. That's literally what it is. The tools that you use in responsible AI are very varied, but like I said, you need to use audit frameworks to audit your data. That's also part of responsible AI. Governance boards, policy alignment. This one is purely quite a technical component that has got specific models like LIME, SHARP, and GRIDE that literally can, like we saw there, we're saying you can actually hook it up to a model before and out of it. And what it does, it actually helps to explain and create some charts around exactly why the decision was made. This is literally to address the black box models. The white box models are quite clear. We know exactly what comes in. We know exactly what comes out. Right. Then the compliance and relevance is also quite important. Responsible AI is saying you should comply to specific guidelines of accountability and regulatory mechanism. But explaining AI is talking about what we call the right to explanation, right? So the right to explanation is that one. That's literally explainable AI to say, you have a right to tell me why you didn't accept my application, right? But ethical is looking at deeper things. Does it harm society and all that stuff? So there's a bit of, I mean, obviously there's an overlap because this is a subset of the bigger scope, right? So responsible AI is literally exactly what we spoke about, in the sense, I think we've already spoken about the key capabilities, the fairness, the transparency, human oversight, and compliance itself. Then obviously I'm just putting in some mathematics here, but obviously I don't think, but what we're looking at is one of the metrics that we need in responsible AI is to say, what is the latency, the impact of latency on accuracy? Because remember, once you put these things into the model to also be able to assist and check the validity and the accuracy and sensitivity of it, there's some time latency that gets introduced as well, because you have to pause and actually analyze the outcome and the input as well. Then obviously one of the key parts is, how do we calculate the bias? So in that case, we'll say we've got an expected outcome that we expect, whether it's a true or false, and then we've got the real outcome that came out. What is the variance around it? So in that case, that fairness checkpoint, we can be able to calculate the bias and then feed back into the model and say, this is the bias, and can you improve and reduce that bias, right? So ultimately what happens, we'll calculate what we call an explainable score, where we can actually be able to see these decisions, whether they affected the human workflow or not. That's literally quite a very critical one. Then obviously we have got something called governance in the AI workflow world, which quite a lot of capabilities. We've got the governance element, which is looking at the policy framework. This is where you establish the rules and the guidelines and compliance principles for AI, and to say, these are the decision rules that needs to be encoded in a BPMN model. You understand my point? So in audit and the compliance logic, what rules and responsibility does each one needs to have? Business owners, data scientists, and anybody involved. Then there's transparency in terms of the outcome. This is now explainable AI, the decision logs, the annotated BPM workflow, the dashboards for model outputs. All those kind of things are quite key. Then also what you call risk management, right? So in terms of risk, we need to identify and evaluate and mitigate risks that can happen in this mode, in these workflows that have got AI embedded in them, right? So the risk checkpoints in workflows might specifically for out of threshold AI outputs. Then we can send an email to a specific business use, whatever, or can ever dash these weird outcomes that came out from the model, right? Then we can also have experts look at it or business look at it and make that. Then we've got what we call the model lifecycle management, which looks at governance of the model, retraining of it based on all these outcomes, decommissioning if it's not performing well, performance monitoring it, and making sure that it's aligning to our expected outcome of the model as well. So this is now a combination of the BPMN model and the AI model, right? And then you also got the auditability of the model, where you are literally looking at, I need to audit the model, like we say. The only thing that really helps us here is the audits that we create in the workflow and see the output of the workflow and of the AI model. And normally we have things like process mining that are able then to actually analyze this data, and the process mining outcomes can be able to tell us and say, this is some of the problems that we're getting from the AI model, or vice versa, right? Then literally would expect organizations to form these ethical review committees that then look at all these gatekeepers and put manual approvals where they feel maybe they need to assess the models a bit more very closely before they actually remove those human models, the human intervention in the loop. Then obviously it's got data governance that look at, was one of the key things that you also look at when you have AI models, data privacy, big problem, right? Because you're gonna put in data into a model. You're gonna call OpenAI. You're gonna call this model. The question is, you're exposing your data. The question is, what's the security level is there? And what's the privacy mechanism? Can you do some masking of the data so that at least you get a point? Can you also prevent sort of data lineage around it? Those are all kind of very key things. You understand? Then you also obviously have to have continuous improvement, where you say wherever you detect failure and a human interjects and fixes it, the model needs to be told and it needs to learn and retrain itself and actually not make the same mistake again. That's quite important in terms of the governance. Then we also have what we call collaboration. The question is, the responsible AI is introducing collaboration. We already have role players in the workflow. And responsible AI is saying, what are these people in the workflow? You have technologists, you have the legal team, you have ethicists. So one of the key things we've never really involved a lot in workflow engineering is ethicist, right? You understand? But because now we're introducing this AI, the ethicists are quite important because they're coming in also to make sure that whatever that we are using doesn't damage society, doesn't go against our cultural values. So it's no point to actually use AI to hire an employee, but when we had some bias and we rejected a Chinese employee, a potential employee, and we accepted a black employee, and vice versa. So as long as you've got bias, then your model is going against some of these ethics as well. So that's quite very, very important. Then there's traceability of it. I think we've already spoken much about it. Auditability and feedback loops. I think that's okay. Then obviously, I think if you look at some of the key outcomes and key components, we obviously discuss about what we call the rise of explainable AI. That's exactly what we spoke about, in the sense that you enable trust, you support audit, and you make room for appeal, so that at least a human can ask to say, why did you say no, right? Then there has to be an explanation. You can't just say, it's a model, I don't know, right? Then there's what we call federated learning of data, where a model trained across decentralized data sources without centralizing sensitives. So this is quite important, especially in talk of banking, talk of insurance. They can keep their data in their own companies. They can send data to centralized, they can train the model directly from their own. They don't have to send the data to a centralized source. They can train the data from their own. It's more or less like the way blockchain is designed, and which means they keep the data, but they send the results of the model, of the training, to a centralized data center, so that it contributes to the model, but they keep the data. So that's why we call federated learning of data, or data privacy. So you actually, it's literally something that has to be used in finance, because you don't want to share your customer data, but at the same time, you want to train a model, but your data is not enough, right? So if you've got 10 banks and you combine the data model in one society, then you've got more, because it's pointless. You want to build your own data, you've got 2% market share, it doesn't help, right? So ideally, you want all the banks to have some kind of centralized data model, but how you build it, you don't have to send the data to somewhere centralized. You can actually build the data from your own source. So that's something that's quite very important. There's something that's also quite key in terms of privacy, which is also a key component of responsible AI. Then when you look at ethical AI, that's exactly what I said. You want libraries that assess and monitor and improve ethical behavior of AI systems, and they reduce bias and transparency. Then we've got governance, where it becomes strategic to do an oversight, where the committees will actually look at the results of the model at regular periods and see. And one of the key things that we discuss in terms of responsible AI in the workflows is a concept called automation as a force of good, right? So what it does, it promotes equity, increases accessibility. So this is another thing. If your technology is also not accessible to everyone, maybe it's not accessible to a certain race, it becomes a problem of ethics and a problem of society per se. So you might say, oh, okay, we've got this sleek product and it's only available to our private customers or private clients. You understand? So the question is, where the automation is a force of good, as far as responsible AI and automation is concerned, is to say you should try to create equity. You should ensure fair treatment across all demographics and social groups. You should reduce discrimination and foster inclusion, right? You should increase accessibility, sustainability, and public trust of your model, because it's no point for a model to only work for one group of society, because then you've got a problem, right? Then I think obviously some of the key takeaways is ethics might guide AI development. Human oversight is quite important. Responsible AI boosts The trust, I think I've already kind of highlighted federated learning, where we've got decentralized machine learning, trains moderated and correctly without sharing raw data, then improves data privacy and stuff like that. Then, what are some of the key areas is obviously in the health space, as much as in the finance, it's the same kind of stuff. Then if you look here, we also talk about the toolkits that we're discussing. These are frameworks and libraries that help evaluate and enforce ethical principles. They ensure fairness, privacy, and transparency. And you need to include metrics and bias tests at regular intervals, more or less like you do penetration testing of existing software. The models need to have bias tests, and the metrics of those bias tests are your results of your model, right? So they can be part of a software engineering lifecycle where you've got functional tests, regression tests, penetration tests, then you've got bias tests against the AI model, right? Then these are some of the toolkits. We've got what we call the IBM AI Fairness Toolkit, which is a 360-degree model. Then we've got the Google What If tool. Then we've got the Microsoft Fairlane. Then the OpenAI Evaluation Model for Assessment, and the Ethical Matrix tool. So those are some of the key ethical AI toolkits that you're going to get out there as well. Then obviously, I mean, we're discussing in terms of those are the three trains that we're looking at, and obviously in terms of strategy. Then I'm going to speak about a bit more about what I call the black box model in AI. A black box model, I think we've already explained to say these are where we can't see things that's outcome out of it. And the most popular ones is the deep learning and proprietary AI systems, like even your ChatGPTs, they're all proprietary. Your DeepSeek is definitely not. They actually made it available. Then the less transparency, they're hard to validate, to explain. They've got legal and ethical concerns. So that's the problem which we're facing with most of the models that are out there, or mostly used, because most of them are actually hidden. They're proprietary because these are mostly private companies. But you see, most of governments are actually enforcing these things now to see how they solve that. The EU Act is obviously looking at something on that model. Then they also create problems in the sense that you've got obscure decision paths that make error detection very difficult. You've got inconsistent outcomes across similar cases. You've got non-compliance with data protection laws because you have no idea what they're doing inside, right? You have no idea if they're discriminatory or not. You have no idea as well in terms of the success criteria that they're using, right? So the question is, how do we make them more explainable, even though they remain black box? That's where those explainable AI model agnostic tools are coming in to assist. They literally do a post hoc analysis of the model to check. They also do some kind of regular reviews of it, and they actually try to introduce some interpretability into that model, even in that black box. And they also, one of the key things is to say, at least we should have some documentation and visualization of the decisions. But unfortunately, we don't have a view of how they calculate and stuff like that. So responsible AI is a strategic component and enables us to build user strengths and obviously prevent litigation. The bottom part is quite very key. Prevent costly litigation and bias exposure, because you've seen companies that have violated that. Some of them have gone bankrupt by taking pictures of someone. Somebody is going to court, and they've actually gone bankrupt. So that's some of the issue as well around those things. These are some of the acts that you're looking at: the GDPR Act, the AI Act, the IEEE Ethical Design Act, and the US Blueprint of AI or Bill of Rights. So there's more. I think obviously in the African space, they're still a little bit behind, but they're also being asked to actually adopt some of this to ensure that fairness. Then we also what you call the AI risk framework, which is looking at the risk, the impact analysis of the affected individual, the model, the data lineage, the human in the loop, and the fairness of that. Then obviously when we design ethical workflows, what should we do? We should actually introduce sensitive decision point, we should have regular audits. I think we've discussed on this one. Then I think we've also discussed more around the black box AI model. And we've also looked at risk of the AI model. The black box, the logic is very opaque. The biases are undetected and stuff like that. You understand? Then I think if you also go to how do we make them explainable? I think we've already explained. We can combine the Blacksmore model with what they call interpretable surrogates, and we can leverage model agnostic, and we can use explainable too. So those are all your 3 or 4 strategies that you're looking at, and you can improve the visualization of the decision points. Yeah, so literally then, obviously, I think you also need to align with ESG goals. So I think for those, when we talk about ESG goals, we're talking about environmental, we're talking about climate change. So your models, one of the key things that's been attacked on AI is the fact that it actually is doing a reversal of climate change objectives of organizations, because it consumes a lot of energy. It consumes a lot of power in terms of power. So the question is, how do we align and make sure that most of these models are actually energy compliant and stuff like that? So that becomes also part of the certification of responsible AI. Like we said, responsible AI is saying, do not harm society. So you can still have an algorithm that does very well, but consumes maybe 2 gigawatts of electricity, and you've got a society where they actually don't have power. So the question is, how do we balance the issue of energy consumption and the output of a model? So literally, those are some of the key things that are quite important in the ethics component. Then I think we've already explained most of this. Then this is more or less what I call a risk framework, which is looking at some of this to say you need to make your model transparent, fairness, the quality should be traceable, and risk classification. So you need to, at some point, classify your model as a low, medium, high. The same way you classify an individual as a low, medium, high. So risk should also be classified low, medium, high of the model, right? So in that case, that's literally also something that you're looking at. Then in that case, also in terms of the ethical, so here I'm now looking at a workflow model. You need to map all workflow automation touch points, identify, mark them. You need to identify decision affecting rights, tab gateways related to loan approval and stuff like that. You need to incorporate explainability. I think we've already discussed that. Then human in the loop that can follow a specific AI integration. Then you've got a look and accountability. So those are the key components of what I call an ethical compliant workflow. So say we're trying to make sure that our software engineering is compliant in terms of the human aspect. That's what you're looking at. Then obviously Camunda is exactly one of the tools that we look at. These are some of the tools that it uses. It uses BPMN and DMN in terms of the modeling culture of it. It's literally based on its APIs are literally based on REST API, GraphQL, and all that. Then in terms of that, I think that's literally what you're looking at in terms of the ethical part of it is the bias detection, user consent. So that's also quite a key one. In some cases, you want a customer to consent if you're going to do facial recognition. So they go online, you try to do facial recognition on their case. Did you seek consent? Then you also need to use what we call the data minimization strategy. Is don't ask the customer or don't get more data. That's more than what you want to do. So if all you wanted to do was to verify a customer's creditworthiness, or there should be no reason for you to get other details that are not related to the decision you want to do. So you should actually follow what we call the need to know basis of your model. So you should have a model that literally say, if it's going to make a decision of your creditworthiness, it should not ask other parameters that have no relation to calculating the credit relation. So that's quite important. So that's really something that needs to be emphasized, to say the model shouldn't take more data than NUMA, and they should determine it, and you should ask the customer to consent. That's quite very important, right? So the aid bias mitigation strategies, I think those ones we've discussed. The human in the loop, I think we've discussed. The continuous feedback, I think that's also quite a key one. And the role-based access is also quite important. I think this is normal, therefore, a standard in every workflow to access control. assign responsibility of the role by roles in the model. So this is where the human gets involved. So this is obviously standard stuff on a workload. So this is obviously, these are algorithms that I'm saying that enable your explainable workflow. It does predictions by approximating the black box model with a local interpreted model. So what happens is it takes a black box model, and it's got its own model that is interpretable. Then it does some kind of approximations using some mathematical algorithms. Then it comes up with an output. And you can see these are coming from the same vendor, so they kind of know the black box model itself. And they are literally trying to supply a local interpretable model and then be able to calculate and assist in that. Then the sharp one is also another one where it assigns a feature of importance to every prediction but it's based on game theory mathematics, and is consistent, is theoretically grounded, and it supports complex models as well. So those are so this is quite a very quite also interesting field for those who want to go into it. Is responsible AI. You can see it's got a lot of capabilities, and it plays a very important part in auditing. So that's quite a key skill that auditors actually need to have, because now when they go and audit companies and they don't have this skill, it becomes difficult because it's no longer data in a database where they take data and start analyzing it. This is data being implemented by a model. So obviously, decision trees and black models, I think we've already spoken much around it to say, okay, remember what I say, decision trees representing white box models. There's transparency, perfect. Black box, definitely not. There is interpretability, yes. Black box, they actually need those external tools to explain. Auditability, definitely is. Difficult because they've got a lot of hidden layers. For those who've done deep learning, you've got all this hidden layer, what, and all that in your mathematical algorithm. The suitability of explainable AI is naturally explainable, very clear, right? X plus BY, A plus BC, right? But they need external explainers. Then performance may underperform on complex data, which is correct. I mean, decision we know, like decision trees, those simple linear regression, when it comes to big data, they can't really do well, right? That's how the past decade, the whole AI has been transformed by deep learning, because even though it's a black box, it's literally can really give you a lot of results. It can do visual recognition, so all those things have been brought in by most of these black box models, but they're a bit poor on explainability. Then we've got compliance readiness, which is also looking at regulatory environments, and obviously here there's a lot of problems in terms of compliance because they can't be explained, right? Then the other part is what they call heat maps. They highlight. So this is mostly applying now to non-textual data. So when it comes to analyzing that in terms of responsible AI, so if you are going to validate a Word document, a proof of residence in your workflow for a bank, yeah, there you've got a problem. So once you've done that, you actually then you use these kind of techniques, or you're actually looking at a medical image, where you look at tumor localization. They can be bad. In the outcome, and you can actually diagnose someone wrongly, which is actually very dangerous. So literally, these heat maps help you a lot, because they show you the concentration levels and actually help in terms of like, okay, this is in terms of making your decision as a doctor or a radiographer, whatever you call it, right? So I think this one, we spoke about it a bit, what you call counterfactual. They show how minimum changes to your input can change the decision. So it's quite important that even your credit people or something, to say, if the income were 5,000 higher, would the loan would it have been approved? You understand? But they've analyzed the data, and maybe they actually want to vary it, because remember, the model is also helping the business to actually also vary. Maybe they didn't put a correct threshold, right? So they will analyze the results and see to ensure a bit more fairness. Do we need to lower it down a bit to 65%? Does it introduce a bit of risk? So they're looking at all that as well. So I think that's what you're looking at in those 5 key components of explainable AI in terms of that. So I think literally, more or less, the principles of ethics are obviously promote well-being and positive outcome. they call it beneficence. Then non-malfeasance is avoid causing harm. Then autonomy is respect the human and ensure consent from him. Then ensure justice by making sure equitable trade treatment. Then explicability is you make decisions that are explainable and transparent. So then the challenge is obviously there's lack of unbiased data, there's difficulty in measuring fairness, there's trade-offs between accuracy, there's regulatory ambiguity, which is quite a big problem because most of the governments don't have the level of knowledge. This is quite very new stuff. Everyone's trying to catch up, right? Governments are trying to catch up. So right now it's quite a very big problem because there's a lot of compliance gap, there's a lot of ambiguity. Then obviously those are some of the challenges that we have at the moment, which are actually creating problems, but obviously can be solved by this governance board, guidelines and training of AI stuff. It becomes quite important for everyone to be aware of AI as well. Then I think as far as maybe a BPM model is concerned, one of the key capabilities that ensures transparency, the BPM modeling tool itself has to be process transparency. Everything needs to be very clear, right? The DMN model needs to have some auditability, the human in the loop, then there's process history logs, there should be ethical checkpoints. Then if I go down, obviously I look at the dimensions of what I call a risk assessment framework. Is the question is of an audit framework of responsible AI is called key dimensions. Who is affected by who? What is the probability of harming? What is the severity of the damage? What is the scope and complexity? And what is the governance oversight of it, right? So those are some of the, so literally the risk framework is literally has got 4 steps: the identification of the risk, the analysis of the risk, and the mitigation of the risk, and the monitoring of the risk. So those are your 4 key things in terms of that. And these are the tools, I think we've spoken most of them, the explainable tools, fairness metrics tools, the demographic parity. So this is quite important because we're checking your data if you actually included all demographics before you made a decision. Did you give equal opportunity? Then we've got model performance outcomes. For those who have done AI, you know all this, like your recall and your ROIC. Then we've got risk scorecards that quantify the grade of a risk and the training of it. Then the red teaming, which is quite important because I think we spoke earlier about what we call adversarial networks. So those are quite key ones in AI because they're doing the opposite, right? They're going to attack your model and try to see whether your model is going to be deceived, right? You know what I say? So that's quite key in terms of what we call red teaming. So adversarial networks are very, very important to validate your model to make sure that it does it with state, right? So that's quite important. Yeah, so the fairness model from IBM is an open source toolkit that can detect and mitigate bias, and it's got 70 fairness metrics that it uses so that you can measure the metrics. Then you've got mitigation algorithms, and then it's compatible with Python machine learning pipelines and extensively used in research and enterprise. Then you also got the Google What If, which is a visual interface to inspect machine learning models without writing code, and it visualizes the decision boundaries, the counterfactuals, which we've spoken about, and it also then integrates to TensorBoard. I think for those who know, deep learning has got what you call TensorFlow, and it generates TensorBoard, and from there you integrate with it. Then we've got the Microsoft LA, which is literally something that is a mitigation library for machine learning models that looks at capability and say, what are the disparity metrics across sensitive groups? You've got your Chinese community, your Indian community, your Black community, your white community, your community. So it just depends, right? So that's quite important. Then it's got what you call post-training reweighting algorithm. So which literally then tries to say, we have done the training and we have to reweigh, and we have to also self-correct based on corrections that come from the individual. So that's what it does, but it's got APIs, which is quite brilliant, right? So you can integrate it and you can be able to use it together with your machine learning model, right? Then you've got obviously evaluation framework for large language models and generative models, which also introduce quite a lot of risk. They introduce what we call hallucinations. And sometimes they just pop up things from somewhere. I mean, we've seen it, depending on your prompt. So the question is, how do you look at the behavior and benchmarking? How do you evaluate? So this is literally to address large language models in terms of ethical shortfalls that they introduce. So literally, just allow me to just go back a bit. So the matrix tool is literally saying the ethical matrix tools are decision frameworks to evaluate in AI on various stakeholders, then the moral rules, the stakeholders, and there has to be some what we call a consensus building. So I think this one we've discussed about a loan origination that needs to have a fair lending outcome, and HR needs to also have fair resume screening. So you cannot write an AI model that goes into LinkedIn and doesn't do fair modeling on using your natural language processing, and you then exclude other people if that's what you're using, or you allow people to upload CVs. Then your algorithm is really looking at gender. So it's quite. I think some of them mitigate it by actually saying when you upload your CV, please don't tell us your gender, right? Please don't tell us your source country, right? So you have seen it. So it's actually being trying to prevent the bias. So at least you can submit something. In some cases, I mean, they say please don't tell us your age, because sometimes people are like, okay, this one is maybe 50 years old, so we don't want. You understand my point? So it's already biased, if you think about it. So that's literally some of the key things that you're looking at in that sense. Then if you look at claims, you look at what you call a triage using a machine learning classifier, fraud detection using what you call anomaly detection. Then you also got extensive AI to explain the reasons of the rejection, right? So that's literally. Then if you look at a bot literally also might talk to you. It might be biased. That's exactly what it might do. So it resolves common queries. It escalates logic for sensitive complaints. So that's what you then say. If it's a sensitive complaint, the bot should not make a decision. Should actually escalate to a human. What fairness more are you having on these responses that it does? Because the problem is a bot might be speaking to a 70-year-old and a 50-year-old. A 70-year-old might be offended by the language of the bot, right? A 50-year-old maybe not, right? So the question is, what's the fairness of the model in giving responses? And also maybe I might not be in a good mood, and if the model just tells me, what, I don't give a damn. That's why sometimes people are like, you know what, I don't want to talk to a bot now. Can I speak to the consultant, please? You understand? You have seen it, right? So I don't want to. I'm going to go to the branch. I want to speak to a person. I don't want to speak to that whole thing. So it's mostly because sometimes the responses are not sensitive to the mood of the person, which is the problem it is on, right? Then I think if you look at text compliancy, obviously look at a rule-based engine. That's what you normally have, and you've got discrepancy around that. Then the question is, how do you survive that? So that's something that you're looking at. I think we've kind of already discussed around it. So that's literally more or less, I think I was top there my presentation. One thing that we obviously didn't cover much is what we call agentic AI and the risk that it presents. And maybe that will be for another day, because it's something that's just literally came into the picture. And they also bring their own bias, these agents and stuff like that. But they're not very far off because they're all AI based. So yeah. Okay, I think I'll take some questions. Maybe for the next 10 minutes or so, then we can wrap up. I don't know if there's any questions from the team. I can't see who's raising the hand. So Dumakaso, maybe you need to moderate and see who's raising hand. Then at least I can be able to respond. Okay, I don't know if you guys can hear me. Yeah. Dumakaso, you there? Or anybody who's got a question, maybe you can just shout. Okay. I think I'll stop the sharing and just see if there's any. Just allow me. Right. Okay. I don't know if there's any questions from the team. No, you can just raise your hand if there's any topic that you want clarification or something like that. I will be sharing the recording in any case. So if you want to play it, okay, I see there's something on the chat. Okay, all right, let's just something later on. At least I know you normally ask questions. Do you have anything to ask, or you still need to digest? Okay. All right. Thanks so much. But I think we'll be able to share the recording for those who want to follow the this topic, and maybe just if you're quite interested in it, you can chat to me. Like I said, it's quite a very specialized topic, but combining it with workflow is quite also an exciting feature that you can actually learn, because you guys already understanding software engineering and workflow. And this is not necessarily workflow related, but something you can be able to integrate it to even normal Java programming or workflow. It doesn't matter. Either of the two will still be applicable. All right. Okay. Justin, got any questions?
Anissa did put something on the chat.
Okay. Let me quickly share. Is there a way of possibility of standardizing these metrics to check for biases? Like I said, I mean, we've got all those different explainable AI algorithms from the top major vendors. Yeah, so they definitely have in terms of, but I agree with you. You'll find that maybe Microsoft have got a different way, which also creates problems, right? Because they've got it their own, and if their explainable AI tools are actually not visible, or they're also black box, then also got another problem. You know what I'm saying? So I think, but I'll try to also find out in terms of that, but that also creates a problem in the sense that the auditing tool itself is not explainable on its own. Then it also becomes a problem. Understand? Okay. All right. Thanks so much. We'll share the recording. I think it will be on YouTube, and you should be able to follow it as well. Yeah. All right. Thank you. Okay.